Welcome to Chapter 8.3, Rocks Under Pressure of the Dynamic Earth, Chapter 8. So far, this chapter, we have discussed the Earth's crust and how thin that crust is and the different layers that make up the Earth. We've also discussed plate tectonics and how the large plates interact with each other, whether they're moving into each other or away from each other or just sliding back and forth between each other. And we've seen how solid rock can be pulled, bent and twisted to serve the will of the convection of the magma underneath the Earth that moves in this constant cycle that pushes the plates around and around. What we're looking at today is how specifically some of these bendings and pullings occur. What we have here is a picture of Hamersley Gorge, Hamersley Gorge National Park in Western Australia. We can see here the tightly folded strata of rock that's been folded in amongst itself again and again and again as the movement of the ages moves through and rocks form as they do. And you think about the large amount of energy that would have had to have gone into forming this, pattern of striations in this rock. And these kind of large energy forces, cause the rolling hills and valleys that we see and enjoy today. The first thing we're going to look at is one of the forces that we have. In this case, we have pressure upon a piece of land from both sides, pressure heading into this piece of land from both sides. And as a result of this pressure, we get a bit of a squeezing of this piece of land, and it actually bends and creates a ridge in the middle as the pressure comes in from both sides. So these are often actually far below the Earth, more down here, and we often really only see them when we dig roads and there's avalanches and things, but we do sometimes see these rips and ditches in the surface as well. So some terminology for you. The tops here are called the anticline, and the bottom here, the dip, is called the syncline. Anticline, syncline. Anticline, syncline. Okay? So Australia's a really good example of these kind of folds and rips and ditches. For some reason I'm calling them a rip and ditches. You know what I'm called, a ridge and ditches. But anyway, we'll leave that in. A big example in Australia is the Great Dividing Range. Okay? This is one big anticline, okay? And there is all sorts of bending of the Earth that goes on in these areas. But there's also the Flinders Ranges, the Barkly Ranges, McDonnell, Musgrave, Nullarbor, Kimberley and Hamersley. These are all as a result of these forces that have caused these anticlines. Now, unfortunately, sometimes it's not so nice, and the Earth does, in fact, crack and break, and we get what's called faults. Okay, there's a big fault line that runs through the middle or just above Adelaide, and this fault line causes the areas here to break and collapse a bit, and that's why there's sea here. So we can see there's this horst here, which kind of runs down that way. There's a horst here, and these sections have dropped down here. So on here we've got the Spencer Gulf, it's up here. York Peninsula is kind of on this ridge, which is here. Okay. Then we have the Gulf of St. Vincent, which is here. And then we've got Adelaide, which is here. You can see how it's basically matching up. And these rift valleys form when we have the rocks break and crack and on a fault line. This is often called rift valleys, as I was saying, and this is called the Horst. Now, sometimes we have a fault line that doesn't create a Horst or any of these kind of things. It's just one long slip fault, as it's called, and the best example of this is the San Andreas fault, which we saw last time. That's one long fault line, as they say, in the earth. So yeah, that's it for me. Go to chapter 8.3, Rocks Under Pressure, and copy the blue words into Quizlet, and I'll see you in class.